As CO2 emissions continue to rise in our atmosphere, within the healthcare sector, we have a role and responsibility to reduce our emissions to as close to zero as possible. As things stand, the health sector contributes to about 4 to 5% of emissions globally. Now we're standing here in an operating theatre. Operating theatres and operations have a significant carbon burden associated with their use. And we have a role and responsibility working within these settings to try and reduce our carbon emissions and environmental impact. Working closely with our healthcare estates teams and our academic teams, we've worked out and seen where the high energy usage comes from within the operating theatre. Now, about half of our energy use comes from things such as lights, computers and medical equipment, but the other half comes from the way that we ventilate our air within the operating theatres. I'm standing here under a laminar flow air system which provides ultra clean ventilation to the atmosphere that we work within, but it has a significant energy burden associated with it. And more often than not, these ventilation systems are running 24 hours a day, 365 days a year. We don't need to do that. The government guidance recommends that we turn off our ventilation systems out of hours, because there are no humans within the theatre out of hours, therefore there's no biological burden to the environment in which we work in. During our project, we've explored not just the built environment that we look at, but we've looked to see not just the built environment and how we can save energy within our operating theatres, but we've looked to see how we can potentially reduce the size of our operating theatres by getting rid of things such as scrub sinks and anaesthetic rooms. And by doing that, you have a smaller space to ventilate, you reduce the duplication of equipment, and that in itself can reduce our carbon impact.
Part of the study looks at the actual layout of the operating theatre suite, which is in the UK how we define the space within the operating department. Europeans and Americans quite often just have a single operating room and everything is described as the OR. But we have a series of rooms, and according to the health building note, there are options about how you actually lay these out, and you can have the scrub within the theatre, or you can have it in an adjoining space which may or may not have a door. You also have the opportunity to relocate the dirty utility outside the theatre, or you can share it with another theatre. The rooms that cannot be shared at present are the anaesthetic rooms and the preparation rooms. And these are the two rooms which we are looking at on different arrangements about how these can be best configured to give a more net zero carbon solution to energy saving problems. There's a lot of duplication with anaesthetic rooms, and the other one is the fact that the preparation room is definitely essential, and it is also part of the major European models, whereby we're using different methods of ventilation dependent upon the type of situation required.
My name is Remko Noor. I give you a short tour through the most modern OR of the world from Maximuse. We have a different approach for design. We put the patient in the center of the design and design the comfortable work environment for the medical staff around him. Next to patient safety and comfort for staff, we guide behavior by design. We look at different logistics flows in an OR and around the OR to make the optimal design for everybody. So is the OR easy to clean and disinfect because of the seamless walls, floors and seamless ceiling. In the ceiling, all aspects are integrated, so no obstacles are in the way for the medical staff. We add circadian LED lighting with different colors in the ceiling. We have a temperature controlled airflow system with HEPA filtered air for contamination control and comfort of staff. We have a full integrated IT system including imaging, patient files, room control and all other digital aspects for surgical procedures. And with this clean room approach we create a safe and sustainable OR towards our net zero goal in 2030 according to the Paris Agreement from 2015.
The challenge, obviously, for the mechanical engineering system is that the air comes in at a temperature generally much lower than the temperature you require it at, which is about 20 degrees, 21 degrees, depending on what surgery you're doing. And that increase in temperature must be achieved through heating, either through gas or electricity. The ACH, the air change per hour, typically for the room is probably about 25, giving about 1.2 cubic meters per second for the theatre. Overall, it's about 1.8. Vertical line here shows a typical room volume for a theatre in the UK, 55 square metres, floor area, 3 metres height. And the triangles show the volumetric airflow for ultra laminar flow facility, temperature controlled, and also conventional. To condition the air to a nominal 20 degrees centigrade in the theatre, we need air handling units which draw in air from outside and precondition it so that it can enter the hospital operating theatre. Image on the right hand side kind of shows the contrast between the Queen Square Hospital, Victorian Hospital, a very beautiful building, and air handling units that are sitting on the top of one of the annexes. Typical configuration, usually they're covered. This is actually an electrical air handling unit, fully electric. Draws in air from the bottom, goes through the bottom section of the air handling unit, and the exhaust is going over the top, and there'll be a energy recovery system. Left hand side kind of contrasts Royal National Orthopaedic Hospital, their new fully electric heat pump system for heating and cooling the air coming in. We see the solar panel array on one of their buildings. That kind of contrasts with a more typical scenario of a energy centre that will consist of a gas powered boiler. HTMO3 requires that the theatre is put in setback operation when not in use. Most theatres, in our experience, are really not in that position at the moment, although they're mandated to do that. If we do put things in setback operation, typically it's not like your television, it tends to go down, airflow rate tends to go down by 50% because the fan usually has a fixed angle, blade angle, and so has some instabilities below about 40% of the typical speed of operation. But that reduces the energy cost by about 40%. If it's turned off outside the working day, which might extend to Saturday and Sunday, then there's a 60% reduction, and if we switch off at the weekends, then there's a 70% reduction. Coupled with this, coupled with the removal of the anaesthetic room, will also lead to a reduction of about 15%. So all in all, we can have an 80% reduction if we design our spaces to be to take into account new ventilation strategies and design them so that they can be turned off through a safe and secure process that doesn't affect surgical site infections. So just in summary, there are three approaches to help hospitals approach this net zero target, specifically for hospital theatre suites, the most energy intensive part of the hospital. The first one's architectural, so removal of the anaesthetic room and the scrub room, drawing inspiration from Europe, most is a common practice. Reduces overall costs and simplicity in the infrastructure. Second one, we've seen is very interesting designs from Remko Noor that have two components. The first one is that the temperature control ventilation, which has overall lower energy costs than laminar flow ventilation, slightly superior in terms of creating a ultra clean space. he drew some of his ideas from clean room technology, and so those spaces were hermetically sealed, which have superior infection control capabilities, so very interesting on that side. The third thing is how that space is used. So we have this push towards turning things off, required by HTMO3 to turn things down, but if we can turn things off, then we save a huge amount of energy and reduce that overall CO2 burden. And that part of that energy saving has to come through energy recovery systems. So this is needs to be certainly an addition to most systems, and certainly be factored into this more modern, fully electric systems, integrated systems. So that'll conclude.